This is a fourth of 6 videos on a lab related to studying permanent magnet DC motors. Previous part of this lectures and videos related to motor classification and also modeling, developing a torque speed curve, a little bit more on the theory side. The rest of these videos are really going to be more along the lines of the kind of the practical use of the motor. We've discussed experiments in the previous video, measurements to be made. In order to make those measurements during operation of the motor, got to learn how to run the motor, and so we'll discuss a little bit about that. Part of the lab, of course, is to get experience in doing that. So here's this little hobby motor that we're using in this lab. It's a nice experimental platform. It includes a little DC motor. There's the connections here connect not only to the power to the DC motor, this is the output shaft, but also the connections to an H-bridge that allows us to drive this from an Arduino. And also there's a quadrature encoder included in this. So it's a nice, full package, allows for learning how to run and control the speed of a motor. The SparkFun page gives a nice breakout of these pins for the connector so that it can guide this. So part of the lab is going in and configuring this, making it run, making sure everything's working. Know that there's a power source. That power source is could be a battery pack, or we use a AC/DC adapter. Run this on the benchtop. And note that the power is needed and H-bridge is needed. We'll talk more about that. That's the power level signals. It goes through this H-bridge amplifier. And of course there's the low level signals, which are the measurements, which are the encoder. All of that bypasses the H-bridge. Of course, goes directly to Arduino. Remember, Arduino handles the low power stuff. All the high power stuff has to go through this bridge amplifier. Included in the slides that you can download from the Canvas page is a fritzing version of this if you like that interconnection better. Again, the goals of this little lab study is to get some experience running the motor. How do I drive it? How much power does it take? Just learn about also basic motor drives, the simplest type using an H-bridge. What kind of power sources do you need? Any practical considerations, and making motor speed measurements. In a later video, we'll talk a little bit about the encoders used. Right? Remember, the whole game here is to make some measurements, also to relate that to our modeling of the motor and developing a torque speed curve and insight into those types of characterizations. Again, the motor driver is needed. I'm saying here it's a motor speed controller. We have a drive signal here that's kind of a low power signal that's coming typically from a controller. In this case, like an Arduino, it's a pulse width modulation. Talk more about that in a second. It's required to condition power. So here we have, say, a bus voltage, DC power in this case. It has to be conditioned to drive the input to this, in this case, in the armature circuit of the DC motor. And so, we have an encoder that measures the speeds and so on. So this is just to show you this guy here is required in order to condition the power of that. So what we're using is this IC for DC motors. That's a TB6612FNG motor driver that SparkFun has put on one of their breakout boards. This driver will drive actually 2 motors, and you can learn about that more. The link here to the SparkFun page is a nice hookup guide on SparkFun website for this product. This little driver can be used like on a little robot, say, to drive a differential drive robot, or to drive just 2 motors for different applications. This, pulse width modulation can also be used to drive other types of loads, like solenoids and so on. But in this case, again, it's a motor driver. Again, it has 2 channels for pulse width modulation. You have to give this guy power. There's also inputs here for pulse width modulation inputs. You can see PWM-A there and PWM-B. Those go to the Arduino. Again, that's what the hookup guide will show you how to do, and we'll walk you through that in the lab. Again, if you haven't had just a quick overview, reminder of what pulse width modulation is. Imagine just turning on and off the motor really quickly in order to get an average voltage to the input of the motor. These flyback diodes are there so that when you're switching these things on and off, it kind of prevents the current from going backwards and allows you to get this freewheeling and so on. Again, not a lot that you have to worry about when you use one of these ICs, but the basic idea is higher pulse width modulation gives you a higher average voltage in, lower gives you a lower voltage in. I like this illustration from a book by Kenjo that shows how an H-bridge amplifier by changing, and you can see that it's kind of subtle, but by changing the duty cycle, right? Here's a lower duty cycle, higher duty cycle, and you can change the effective average value applied to the motor. So you can get either a negative voltage or positive voltage with an H-bridge, right? So you can get forward and reverse control of the motor, right? Basic idea of what you're trying to do. The last thing with regard to this quick overview of just driving the motor for this lab, using a battery, just keep in mind batteries decay over time. Also batteries, like any source, the output voltage will tend to vary depending on how much current you're drawing from it. Any power supply, whether it's a battery or an AC/DC adapter, the AC/DC adapters are typically also designed for a particular load. It'll tell you on there what load it's going to drive a certain current at. If you get a regulated adapter, then it gives you that fixed voltage. Nice thing about the H-bridge is it wants a minimum voltage, and then it'll control the voltage level at what you need. Just make sure that you have that minimum DC voltage that's available, and of course it's got to have sufficient current depending on what you're trying to do with your motor. And that's all. Keep in mind that all of these pieces have to come together to make this motor work.